Okay, so we're back yet for another week of fun and games, and the usual reminders. You can look at the YouTube video down below the video in the description. We've got an index for this video, and there's a link for the composite index of several years of us doing this. And I've also got links to the original ROS agriculture stuff that I started indexing, so you can go dig through that. And then we've got a link to the YouTube page where it's got all the videos. You can select one to watch, and there's several other things there. I can never remember what they are. I should write this down so I don't have to make it up every time. And other than that, I guess I'll move into what I've been doing. So one of the things I was playing with was I just wanted to hook something up. I bought some. Let's see, I bought a the load cell that I was showing last week. I bought a load cell on a board and I put it on a pro board. And then I was thinking, well, something I'm trying to do right now. I was trying to remember. Now I can't even remember why I was going to do this, but I decided that you look at these things, and here's a change my view. So here's just is Arduino Nano. It's one of the it's our Arduino Nano version 3, but it's the clone board. It's what they call the CH340 board, because on the back it's got a instead of an FTDI chip that Arduino uses, it's got a down here it's got a CH340 chip to convert the USB. But here's an example. You can buy them like this with no pins on it, and usually when you buy them with no pins, then they'll give you the pins in a bag. So you end up with a bag like this full of pins. You have to solder them on yourself. But sometimes it's handy to have a board with no pins on it, so you can order them this way and solder the pins on, and then order another batch that have the pins, so you don't have to solder them on yourself. But if you're going to do something like this, if you only need 2 or 3 wires hooked up, you can just stick a wire through and solder it. And I know Matt was doing his whole lawn tractor. He had a board like this, and he had all his wires soldered on, and it worked great until he burned up the board, and then he had to unsolder all the wires and solder them onto another one. So that's one thing you can do. Just get a board like that, and it's convenient. Just put the wires through and solder it. And of course, the next option is I don't have one loose here, do I? You can get one that's got buy the board that already got the pins soldered on, so you can just stick that into a proto board like that and just stick wires in to make the thing work. And then if you want to use the I don't have one handy. If you want to use the female jumper pins, in order to make that work, you have to you can stick some header pins in anywhere you want, or just like put pins in, and then you can plug your female jumper onto that, so that works. And then, in fact, here is the one that was that I was talking about last week. That's got an Arduino Nano, and it's got the amplifier board, and it's got this load cell, and that's just a separate piece there. But anyway, that was done the same way. I just plugged the board in, and there's only 4 wires hooked up to the Arduino Nano. So if I wanted to, I could have just run wires and soldered those on. And then what was the next? So, I'm saying I don't have an example, but yeah, here's an example right here where here's that AC power monitor board, and then here's an Arduino on here. It's got pins soldered on it. Well, you can just stick your jumpers right onto the pins if you want to. You don't have to. You don't have to do anything special. So that way you just pull that. If you buy it with the pins soldered on, you pull it out of the box and just shove the wires on, and you're all set and ready to go. And then for some reason I was thinking, well, I wanted to do like this, but in order I didn't have any pins handy that were long enough to plug into here, and then plug a jumper wire into that. So I started looking on Amazon, and I ran across this board. Maybe let's do it this way. Wow. Screen, this one, and yeah, it looks like that's going out. So anyway, this is this, I don't know if they pronounce this Freenove or Freenova, but whatever it is, I'll probably just call it Freenova because Freenove sounds stupid. But it's their universal breakout board, and that's compared to it's still here. No, where did that go? Hold on. And I was going to pause it, but of course my Zoom screen went away. So let me say, let me do this so I don't waste everybody. So this is the I found 2 different boards. This is the one. It's called Freenova, and it's their ESP Yeah, it says ESP32/ESP32S3 breakout board. So this is specifically designed for, it's got a single row of pins to plug your processor into. And if you go look at the you go look at it, it's got an LED on every pin. So that's handy, so you can see what the thing is doing. And you can see that it's got silk screens on there to show you what the thing's doing. Trying to think if there's a convenient way to get a better picture, but no, this is good enough for right now. And it's got a built-in power supply, so you can plug in a coaxial power connector, and it's got a built-in switching regulator, and I think it's also got a linear regulator to give you 5 volts and 3.3 volts. And the nice thing about it is you plug your board in there, and every pin has an LED, and then every pin comes out to the header pins that are the yellow ones. Those are direct connections back to the processor board. So if you want to put jumpers on to connect to something, you can hook to those. Plus, it's got the screw terminals in parallel with that. So you can either get, plug into a header pin, or you can put a wire into the screw terminal and screw it down. And then they've also got the red strip, and then they got the black strip, and the black ones are always ground, and the red ones are tied to on this particular board, the red ones are they're always 5 volts. So if you wanted 3.3, you're screwed. You can't do that. But down at the bottom, you've got a block for the ground pins and a block for the 3.3 volt pins to just make it easier to connect stuff to. And as I say, this one is specifically for their boards. And if you go read it hard enough, you come here, and down at the bottom of this, it says, this is the only place they say this. It says, note, compatible with boards from other brands, or it says, not compatible with boards from other brands due to different pinout. And they're pretty serious about that, because when you buy these, you can get them different widths, depending who's making the board. They come in different widths and different lengths, so it's got different number of pins on it. And then they might redefine where the pins on the board are. So if you want everything to line up, you have to put their processor module onto this particular breakout board. And is anything else I wanted to look at here while we're talking? So it's just showing you nice, cute pictures of it. And what was the other thing? There was one other. Oh, I know what it was. It was this one I wanted to point out. So here they're saying it's got independent LEDs, and it turns out every pin has an LED on. Because if you look at on the right there, you can see a row of LEDs on the left and a row of LEDs on the right. And is there one lit up here? Here, this one says it's showing some lit up. And on this particular board, the 5 volt pin down there, they used a blue LED, and the rest of them are all yellow LEDs. And so that would be a handy feature to have without having to do anything special. You plug it in, and the LEDs are either on or off depending what's happening. So what was the other thing? So I was going to point out, you come back to here, and up here they're saying, oh, this is the way it works. So on the left, they're saying ESP/ESP32/ESP32-S3 GPIO. So it says a pin on your module goes out to a header pin, which is the row of yellow pins. It goes to the terminal block, which is the screw terminal on the right side and left side. So those are in parallel. Then it goes to an inverter, and the inverter then drives an LED as a 10K resistor that goes to VCC. Well, it turns out there is no VCC on this board. So that's a confusing thing right there. And you don't know that until you get the board and try it. And it turns out it's actually connected to the 3.3 volt power supply that is formed by this switching converter down at the bottom here. So that means in order to get those to work, you have to power the board from the coaxial input connector. And then it says if you want to power your board from that power supply, you have to put jumper blocks. Say you have to find, say in this case, did they show? I don't think they're going to show me here because they don't really care. If you go track it down far enough, yeah, maybe this one's trying to tell me that. Come on. No, this one. Come on here. So it says if you want to use the external power, you plug in the coaxial power connector, and then they show stuff lighting up here. And I guess, see, technically, if you zoom in on that, which we can't zoom in right now, but normally if it's powered up, your little eval board will have a power LED that comes on. So in order to get that to work, if you want to power it just like this, you have to put a little jumper block by it. Say on this one, let's go to the top here. So on this one where it says 5 volts at the bottom of that row of LEDs, so that says that pin is designated on their processor as being the 5-volt input pin. So they're saying you have to put a jumper block on the bottom row there between the red pin and the yellow pin. And what that will do, it'll connect that 5 volts to your processor and make the thing run. Because otherwise, I don't think, all the stuff that it talks about, it says reset. I don't think there's any reset button or anything. So I got everything labeled as what the pins are on the board, but they're not necessarily hooked up to anything at this point. So the point is, when you hook it up like this and you plug in the external power, you can see a bunch of LEDs are on. They're hard to see because they're not lit up very bright because they're running them at 3.3 volts with a 10K resistor. So they're not very bright, but it does work. And then you come over here, it says, oh, if you want to run it from the USB cable instead. And this is this is not, again, this is an invalid picture because they cut and paste these things together, so it's not really telling you what you want to know. But here they got the USB cable plugged into their board, and then you can see the LED on the processor module is lit up, is a blue LED. And then they're showing down here in the lower left-hand corner, you can see, come on. You can see there's a blue LED that's on, that's the 5 volts. And I'm trying to think, is that going to actually light up? But I don't think it will, unless this board works differently than the universal one that I bought, because there are a few more LEDs lit up. But I found that you cannot get any LEDs that light up unless you plug in your coaxial power connector. So there's various confusions on how you can run this thing and what you have to do to get it to work. So anyway, I was looking at this one and decided I don't want this one because I had already ordered some ESP32 modules and they're not from this brand. And therefore, they're not, number one, they're too long to fit on this board. And number two, the pinouts are going to be different. And the width probably won't line up either. So if you dig hard enough, you go back, and here they put out another board they call the Universal board. So Universal breakout board. And they show over here, they say, here's different processor types you can put on. And they show an Arduino now. Here again, they're cut and paste, and they got a picture of the board and they pasted it on top. And then here's one called Arduino Micro, and I'm not sure what that board is because I have some that are called Arduino Micros that don't have a USB interface on them. So it could be if you buy it directly from Arduino, they call it a micro, and buy it the Chinese knockoffs, they call something else a micro. So that's another problem you just run into. And here it shows it. Here's Raspberry Pi Pico, and then here's their three different boards that they sell. They say you can plug in there. But the point is these. Yeah, let me see. How can I get this to come up? Well, it's not. Let's see. I don't know if I can get a better picture. Anyway, they're showing here. So you got the row of LEDs on the left and the row of LEDs on the right, and they just simply label them R1 through R24, and on the left they're called L1 through L24. So they don't put any silk screen on there, saying what the board is, because you pull up, well, hey, that's a way I can find this. Let's go look here. So here's the if you download their tutorial, and I don't know if I pointed out that in order, they say, oh, if to know more about the power, go download the tutorial, and that's the one that says you get it on the link is on the box. But if you go out to YouTube, you can find the link and download this ahead of time. So anyway, they're saying here's the board. They're just pointing at various things that are on the board. So I just want to see if I can find a better picture here. And of course, let's see, can I do that? Open a new tab. Well, this is not going to work real well. But anyway, they're just labeling the same. So the universal board, it's got three rows of sockets here on this side and 3 rows of sockets on this side. And therefore you can plug in a chip that's as small as 0.6 inches. And that's what the Nano is. And I have no sense well, I could hold it up, but anyway, the Nano. And if we go back to their picture I just had with, see, that was what, right here. So see, the Nano is narrow, and it's hard to tell from that, but it takes the 2 inside rows of those. And then you get up to the bigger chips. These are a full inch wide on these ESP32 boards. So you can pick and choose, whatever board you have, you got a good chance of it fitting. as long as it's shorter than 24 pins on the side. And so that accounts for the width by looking at the fact that it's got three rows of holes here and 3 rows of holes here. So it's more like a proto board. So you just plug it in where it fits. And then they go to great lengths to say, well, it doesn't matter. Since these are just all independent LEDs and connections, because there's no power actually hooked to the board, and there's no resets or anything. So it's just a convenient way to hook this stuff together. So if you look at this, what was my point? That you got those hooked up there. They're saying it doesn't matter if you plug the can we see that here? So right here, they're trying to tell you, it doesn't matter if you push the board all the way to one end. And here they're actually flipping the board around. So it doesn't matter what direction you plug the board in. So they're saying, here's the USB connector this end, or you can have the USB connector that end. And here they're saying, if you got a short board, you can leave a gap at this end or leave a gap at this end. And a lot of stuff they're doing, they always show it. For some reason, they kind of center it out in the middle, which makes it even harder to try to figure out where to hook your pins up. But that's what they're showing. So they're just go through and explain what all these different power rails are doing. And so this particular board, so the other one had this row of red pins here were always connected to 5 volts, and this one was always connected to 5 volts. This one has the row of pins that aren't hooked to anything, but they come down to this jumper block down here. I would get a closer view of that. Well, not really. Anyway, there's a three pin jumper block down here, and you can put in, if you don't put any jumpers in, these pins are just left floating. And you can put a jumper here between 5 volts and the signal. So you can make this a 5 volt rail, or you can put it between 3.3 volts and the rail. So you can either make these 3.3 volts, or you can make them 5 volts, or just leave the jumper out and they've got no power on them. So it'd be like a distribution bus at that point. And what was the other point here? So here they're saying that if you want it to work, you can plug in the coaxial power connector, which powers up the board, which gives powers to the LEDs. And then they're explaining that right here they've got a jumper block that this will connect. Probably, yeah, this one's going to connect between the red and the yellow. That means it's going to put 5 volts on whichever pin that's connected to here. So that's how you put power on. And all of the ground, any ground on the board is all tied together. You don't have any of this magical switching that you can do with jumpers. So over here, they've got a block right there. And again, it'd be nice if I could zoom in on this, but that's just what you're going to get. And so here's one that connects a ground on the board, and this one over here connects 5 volts on the board. So they're actually powering up this board. This is an actual one they haven't cut and pasted. So by plugging this in, it lights up the LEDs out here, and it powers the board itself. And I don't like the fact that they never come out and say the coaxial connector, get a center positive plug. They got all this trouble and said, well, here's the back of the board. This is where, if you do it right, this is where the polarity will be on that connector. And then so they show the back of the connector, and then they give you a diagram of the connector. So you have to go through and figure it out and say, okay, what's pin 4, and pin 4 is on the end. So yes, this is the center pin, and they're saying that's positive. Well, it's only positive if you plug the right thing in. But they do say it's reverse polarity protected, except one guy said he plugged his board in and immediately began smoking. And so there's like right here somewhere you can't see, there's like a little 3-pin part. I don't know if it's a transistor or diode or whatever it is, but that on the board he plugged in his external connector, and that started smoking. So I don't know if he plugged in an AC adapter instead of DC, or if it wasn't the voltage he said, or if it's just a bad part on the board. There's all kinds of things that can happen there. So anyway, I finally found out the way you have to do is, let's see, it's time for a demo here. Let me do this. So if I say, let's see, stop sharing. Yes. Okay. So anyway, here's my board, and it has an Arduino Nano plugged in. And as they're pointing out, I don't have to put it all the way to this end. I could have slid it down to this end if I wanted to, or sometimes in their demos, they'll center it out in the middle. And since it's got 3 rows of holes across here, there's 3 rows of holes. It's just like at a proto board, you can slide it one way or the other. if you want to, but it just happens to catch the, the middle two rows of holes that works out really well. And something I realized later was I was thinking, well, I've got the header pin sticking up where I can put, see, this one's got a jumper wire plugged into it, or you can put the little shorting blocks on, which is what is here. That's my shorting block to give me ground out to this part here. And then the red one, if I had my red shorting blocks, I could have put a red shorting block between the yellow and the red here, and that'll put 5 volts on this to power the thing. And right now, the ground, let's see, the grounds are tied together. So let me now I'll just leave it on there for a moment. So anyway, you think, okay, all I gotta do is power it up. Well, if you power it up at this point, so if I grab a USB cable and plug in, so you can see the board powers up. It's got the power light on, and I think it's got the blink program in why it's doing that. So you can see it's blinking, and none of the LEDs are on. Well, it turns out they won't come on because you have to have the board powered up to do that. So if I grab a coaxial power connector here and plug that into the board, you'll notice that, say, you can see some of the LEDs at the bottom of the board are on there. So another odd thing is it turns out they use CMOS inverters. See, down the middle of the thing, it's got those inverter chips soldered on. They happen to be 74 HC04 parts, which means they're CMOS parts. And that means if you don't have anything hooked to input, it's floating. And they do mention that tutorial somewhere, I think, because people were complaining. So it turns out a floating input, if I come in here and do this, you can see as I touch it, you can see the oh, it's okay. See, if I have this processor board plugged in, but I don't have power on it, it's holding all those pins down to ground level. But see, down here, as I touch this, I can get I can probably get it from the front too. Well, so let me grab a ground here, put my finger on ground. And then if I do that, oh, it's not as dramatic as I wanted, since it's just doesn't want to play, I guess. But before, if I pop the processor, I can rub my finger up and down, I can get there it's doing it. And you get, so just by me touching those, the LEDs are going on and off. And I thought, well, that's great, but that's a pain. So if I power up, let's see at this point, so if I power up this now, so I finally decided, at least in my case, if I power up both things, if I power up the board itself and then power up the processor with a USB cable, or I can hook up this red wire to the board here, so I can actually, instead of plugging this in, you can do that. So now at this point, you can see the LED on the board is blinking due to the blink program, and then up here, this one on the end is what that's tied to. So you can see that one's blinking, and the rest of them on the board are just basically random, because when the microcontrollers, when they power up, everything's initialized to an input, which is high impedance, and the inverters are high impedance. So you can see the LEDs on the board are just random. I think yeah, so I can still do this as I move my finger up and down. Since those are all set to input, they're not driving anything in that way. Since this board is powered up, they're not dragging everything down the ground. So I got more. It's more fun by touching it. And somewhere there's a video where a guy, I think it's on YouTube, and he was actually using the ESP32 board, but it's the same concept. And he showed a thing, and he had it so he had a ball program, so he could get his LEDs going around in a pattern and so forth. So anyway, it turns out it took me a while to figure out I had to hook up both power supplies to make it work. And then if you don't have a common ground, because I hooked it up and it still didn't work, it turns out you have to have a common ground between your processor board and the main board. So that's what the jumper over here is doing that. And so right now I'm powering it through the USB, and I've got a common ground. And then if I unplug this and then take this wire, I could just use a red shorting block, but I'll do this one to get, let's see, this 5 volts should work. So here I don't have the USB plugged in, and it's you can see the board's powered up, and you can see that LED in the upper left is flashing at the same time the board is. And probably if I touch it, it'll still, yeah, I can still affect those floating inputs there. And so then they said, oh, by the way, so if you're powering it like this and you want to plug in your USB cable here to reprogram it, you really should pull this power lead off here, and then you can plug this in and do your programming. But that's back to the concept where I was telling Bob that if you're hooking your batteries up, don't just have extra, just don't have random leads there, because eventually you will plug it in backwards and blow everything out. So here's a case where they're saying you really should pull the pull your power, and then you can plug this in, and then everybody be happy. And I'm thinking, well, a better way to do that is you can just take a random cable like this and cut it off at about 6 inches, and then put connectors on that. Either put jumper pins on so you can hook it on, or just solder the wires onto the board somewhere. But that way, see, if we unplug this, so the board's not powered, and then we got a cable like this that's hooked onto the 5 volts on the board. If you plug it in here, then the thing powers up. You say, okay, well, now I want to hook it up to the Arduino IDE. So what you do is you unplug this cable, which was powering it from here, and then plug in the cable from your computer. And then again, the computer will now power it, and you can talk to it with with the IDE. And that way you don't have to stop and think about, did I do this? Did I do that? You got one cable or the other plugged in. And if you got the one plugged in from this board into here, then it powers up and runs. And then if you want to hook it up the Arduino, you just unplug that and plug the computer cable in. So that way it takes care of both things. You don't have to worry about that. Now, it turns out this board, I looked up a schematic, which it's hard to tell if it's the real schematic since it's a Chinese knockoff, but this one does have a diode between your USB connector and the 5 volts on the board here. So technically, I don't think it would burn up anything on this. It won't back drive your USB port and blow it out. So that's something, but you'd have to check every board you're going to plug in to find out that's the case. But if you use the trick where you just got just a short lead here that's you got hooked onto the board, and so when this is plugged in, you're powering the board from there. So that switches the power back and forth, and it guarantees you can't have them both hooked up at the same time. So other than that, as I said, the LEDs aren't very bright, and the fact that they, in fact, I touch it like this, I can get them to get the LEDs to change. Now that was pretty dramatic there. So anyway, that's annoying, but again, as long as you understand all the little details here, you can probably figure it out and make it work. And so the main thing is, once you get this plugged in, now you still got all the pins there you can plug into. And the other thing I noticed, I don't know if I mentioned this or not, but since this one, let's see, how can I get that? Since this particular the Arduino Nano uses the 2 inside set of pins, I got 2 more rows of female pins there, so I could plug wires right into there, whether it's the jumper wires, just regular wires. That I think these holes are about the same size you'd find on like an actual Arduino Uno. And so whatever you're able to plug into those and make it work. So there's a good example of that. So now I've got, from every pin, I've got, if you go to the yellow strip here, you can get to a pin and plug into it there, or you got the terminal strip that's connected, or you've also got the female pins here, and you can use any of those things to connect to it. So this does have a good value in the fact that, yes, it makes it easy to hook everything up to it. It's just a matter, you got to go figure out the power and make sure you get all that stuff figured out ahead of time. So anyway, that's I'll play with it some more and try to figure out the good points and the bad points, and then report back later, or just make it a separate video saying, here's what I found out about it. I was thinking I should just go on YouTube, make a video called "Confusion over the Freenove Universal Breakout Board," and then go through and talk about what it says. Here's what they said, but this is what it really does. And you go look at their tutorial, well, it's not really clear. And so anyway, I might do that if I get up the ambition on that. So other than that, I ordered some humidity sensors since my doors don't fit based on the time of year. So those are supposed to show up on Saturday. So I'll try hooking up a humidity sensor and see if I can get that to work, and then try to figure out, maybe get an ESP32 and try to figure out somebody's software to connect that to for a home automation server in my house. So I might get around, try that, and see how all that stuff works out. Other than that, that's pretty much what I've been up to. So we can turn it over to somebody else.
Al, go ahead.
Not a lot of robot stuff to report. I spent time on a Raspberry Pi USB camera thing I have hooked up in Texas to monitor a light that turns on when my water pump goes on and off. So spent time on that. And I guess the only thing robot related is I stopped by Micro Center as I was driving through town in Columbus, Ohio, and trying to see if there are any repair options on my Raspberry Pi 5 that died. It seems like it's 11 months old and there's a 12-month manufacturer warranty, but getting somebody to honor that is a little bit complicated. And well, at this point, Micro Centers said, no, you can return stuff in 30 days. After that, they don't do anything with the manufacturer warranty. And so I've sent a note to the Raspberry Pi Foundation website to see if they'll honor their 12-month warranty. So trying to figure out how to get a warranty on that is a bit of a challenge. That's all I've got, Bob, and but happy to walk through that code that you had questions about on
Yeah,
the
that's a good
RTC.
idea. Let's do that.
So that's it for me from an update.
Okay. Okay, I'll share screen. Screen. Start broadcast. Okay. 1, 2, 3. Okay, it's broadcasting. So now I'll go to, I signed up with chat and got an account. It's free. And I can log into it on my Raspberry Pi or on the iPad. So the idea there is I could go through all the questions, all this stuff on my iPad, but it shows up over at the Raspberry Pi. I can just cut and paste their recommendations right in to a program. I start off with the simplest of questions. How do you use RTC? And it said I have to explain it a lot better. So then down at lower towards the bottom, I said WebRTC on a Pi 5 and an iPad. And it pops up and said, well, you got two options, either a signaling server or web browser. It asks what I like is what I want to do. And it gives me options. If your goal is this with these requirements, here's step 1, step 2, step 3. And at this point, I started looking at that code, and then I looked at Al Jones's code and noticed that they're using AIO RTC. And I said, well, what's that? Is that the equivalent of Janus or what? So I'll get on later. And then here's the code it comes up with. And step 3, open the browser and load the client page. Now we want to remember this step 3 later on. I'll explain. I said, okay, I'm playing dumb. I said, okay, what does that mean? Later on, it generates the code. They offer a simple demo for a no server web page. Before I can continue, what do I want to do? So I chose over in the right, lower right, it shows the results. I picked number 1, 2, and 4. And so it builds it from there. And the overall install This is what I like about it. It goes into better detail of what this stuff is all about. When I put Janus on, it loaded real nice, no hiccups. It just follow the bouncing ball kind of stuff. And then in the end, it said, you're ready for a micro message or a nano message. And I said, well, what the heck? I don't know what that means. And what do I do next? So then that's how I got into this way of doing things. I like it because it explains how to do stuff, and I can inject a question at any point and it explains, like I did back on that number 3. I'll go down to another question that I injected. And of course, it tells me it can send buttons and can connect to motors and stuff like that. And it says this one with hardware is 100, 150 millisecond latency. Or I can add these other things. It tells me what do I want to do next. I don't understand step 3. Open iPad browser and load the client page. Comes back, no problem. And this is what I like. You have 2 small files on the Raspberry Pi. One is the server. I got that. The other one is the web page. And that's what I was asking Al earlier about, where his web page was, because I had some notion that it was off in the cloud or something. But they're saying, no, those 2 files are on your Raspberry Pi. But you must load the page from the Pi. Then it goes on how to load stuff more. So again, at each step here, I can ask a dummy question or a dumb question, and it'll answer and give me more detail as I go. Let's see, there's next thing. It says I can generate a single script, a page, or whatever. What do I want to do? And at this point, instead of picking an option, I said over in the lower right, is all of this just as good as using Janus? And then give me a short answer, what Janus is, what AIORTC is, where Janus might be better. And that's if I scale up to be a big monster, but it's much more complicated. And it gives trade-offs, downsides, conclusion, what's best for me. If you like comparing Janus, right, and this is what I really liked. Compare, pick what you want to do, 1, 2, 3, and 4. And we can do all 4 with one architecture, but you have to upgrade from simple up to a slightly more powerful. So it offers path A, the full node, and it tells me what it's good for. And this is sounding better and better all the time, but it's only up to 1 to 2 clients, and that's all right. Path B, if I went Janus, I get all these bells and whistles, and up to user support, and it just works. Since I chose 1, 2, 3, and 4, I asked it to compare side by side. And this is what really sold me to go Al's way with what he did. The low latency of 80 milliseconds versus Janus, which is 120 milliseconds. And I said, what's easy, what isn't? So at this point, that's when I got on last night and said, okay, how do I get rid of Janus quick and easy? And do I have to go file by file or whatever? And then Al says, no, here's a link where you can just take out the whole package. The chat's recommendation is based on 1, 2, 3, 4 and all this stuff. It recommends the full node and give you a single system that does that. Whoops. Now that it says hardware accelerated, I don't think Raspberry Pi 5 has hardware. So maybe I could look for that hardware encoding upgrade that you can plug on. I don't know. That's something more I have to look into. Then it asks more questions. And I think at this point, this is where I stopped. And this is the other thing I like about chat is I've got this dialogue. Now I can come back to it and say, okay, further explain what you meant in a previous statement. Or I'll say, oh, this is what I really want to do. One of the suggestions was I could put a user interface on the iPad to mimic a joystick and buttons for a robot control. But first, I'll go Al's way and get one-way video first and check it out. So it looks like I've got a good path to develop more and more, given my lack of knowledge on programming. But so that's about where I'm at. And first thing I do is remove Janice from everything. And then I'll start a new thread asking the same question as I did before. So it cleans up this whole transcript. So I'll finish asking, what I'm saying is I'll finish asking all my questions in this transcript or this thread. And then when I get serious to put it on the Pi, I'll know what the exact questions I have to put in. So I'll have to put in my all my hardware that I'm going to use, the specific camera, and use that one to build it, which will go on the Raspberry Pi. So between that and looking at what Al's program was, I'm pretty convinced to go this way instead of Janice. So that's about where I'm at. Let's see. So I'm going to stop sharing. Okay, we're back. So I said, okay. Okay, can you hear me?
Yes.
Okay. So that's about where I'm at right now. But I'm going to also explore Al's program a little more in chat and keep asking questions. And then when I don't understand what that's trying to tell me, then I'll put his in chat again and go through it. Or maybe we could do it here and now.
Well, I mean, there's a lot to go through. I was just going to point out that I started with the simplest thing that I could do, and that was, hold on a second. My son needs something.
Yeah, I think I downloaded.
So this first one, I just labeled it as step 1, and it was literally just to get video going. And the RPi for me was capturing the video and hosting the quote unquote website, so that to view it, all you needed was the IP address and a HTML5 compliant browser. So
Okay.
with this example, I didn't have anything running on, I'll call it the client, other than an HTML5 compliant browser, because it could handle most of, well, it could handle, all of this that was being hosted on the RPi. So I'm only pointing that out to you to say, I don't know WebRTC enough to say whether there's benefits or disadvantages from putting some WebRTC stuff on the client or just leaving it all on the RPi and accessing it via a browser. But
Oh,
I mean, step one for me was just get video working.
yeah.
And step 6 was all about, getting the video with controls, slider bars, and all that other stuff in order to feed it down the to the teensy. So
Okay.
at any point you could always copy one of these programs and say, just ask ChatGPT to explain it
Oh,
to you. Because a noticeable difference for me is I'm using depth AI, and that's because I have a different camera,
okay.
probably than you. I have,
Yeah.
when it talked about hardware acceleration and that H.264, my OAK camera, it does all that stuff.
Oh,
Um, but I still don't think my latency is anywhere near that 80 milliseconds. I think I'm more like 200.
oh,
But I think that'll be fine for,
yeah.
a slow moving deal like I've got. But I mean, I applaud your progress and you're diving into it head first. It looks like you've made a lot of progress, and
I'm beginning to understand how it, I still got a ways to go, but at least I can bother chat and see and get asked more and more defining questions. And so I'm learning quite a bit as I go through it, what this stuff is.
so what camera are you using?
It's a USB logic. Let's see.
What model number is it? Is a Logitech?
Uh, 720p, Peter. 720p.
Yeah, I mean that um yours is going to be a little bit different than mine. I mean, you'd probably just be different libraries. But there will be slight differences because you're using that Logitech
Yeah.
720.
A while back, I did buy a stereo camera, but I don't know where it's packed away at. I might pull that out, but I don't like it because of the flimsy ribbon cables. So in order to move it around, it'd have to be attached to the Pi, and you have to move the Pi. Well, then you got cords and power and all that stuff. So I'll just stick with the yeah, I'll just stick with the USB camera.
Yeah, my only input is um I like I mean I like a lot what you're doing. The only tweak would be decide if you want to have any processing going on the browser side versus just a straight up
Oh,
browser.
sure.
I mean,
We'll
you've got 16.
do the lifting.
I'm sorry.
let the browser do the lifting.
Well, again, like I said, I don't know. I put everything on the RPi and
Oh,
just leave it to be a generic web page that is presented, and as long as you don't use anything different than HTML5 compliant code,
yeah,
um, then on the browser side, you're fine.
okay. Well, like to say, start small and get something going, and then keep trying something else till you break it.
Yeah, you can see it took me 6 steps to work my way up to something that I thought was, close to useful, and
Yeah,
just getting, because it, like all this HTTP stuff is,
yeah, that whole
uh,
different language.
yeah, it is, and it's a whole nother layer, and you got, yeah, it was just confusing to me, so
Yeah,
I wanted to start as simple as I could.
yeah. Well, let's.
Did you have anything else you wanted to pull up?
No, I'm good. Oh, so my goal this for the next week or so is see how much I can mess up.
So those two scripts that were provided, one Python and one HTML, have you put those on your machine? I mean, even if
No,
Janus is on there,
no.
I don't think you have to remove Janus in order to run that other stuff.
Oh, yeah, maybe I could try that. I'm just concerned about, well, that's just going to be in memory, so it's not going to be competing for resources.
Not unless you fire it up.
Right. So maybe I'll just leave it there. So, but I wanted to keep a clean a pie as possible because the previous one I had a lot of junk on there.
I know about that. Back up what you want to save. That's a message that I would deliver, because having to recover from having lost a pie, what a pain
Yeah.
in the butt to try to get back to a
Uh,
working version.
but luckily I've got all the code that chat generated for me on the differential drive and all that stuff. So it'll be cutting and pasting and
Yeah, I mean, let me share with you real quickly, just so you have an example of, let me turn on sharing here. Blah, blah, just like Jeff said, you have to ask, where the heck is the share button? There it is. So my approach to um, coding. So this is FileZilla. FileZilla is, I don't, it's a file transfer utility. Um, and I think I have my RPi turned on upstairs. I do. So over here on the right side is a Raspberry Pi. It happens to be the Raspberry Pi on my tractor. On the left side is my Windows 10 machine. And because I get confused, I just I create a folder on my Windows side for the date that I'm doing something. And then if I know that I want to change, uh, let's not go there. Let's use
oh, okay.
where's the RTC stuff? Where did I put that? I thought that was, oh, maybe it's in testing. Oh, no, there it is. So what's being displayed here on the right side is the file structure of my Raspberry Pi. And I've got this program on my Pi. If I
Okay.
right if I right click that, it gives me these options, one of which is to edit that. Now, because I've got some settings in place, what comes up is an editor on my Windows 10 machine, but it's downloaded this temporary file, and I can, you know, edit this on my Windows 10 machine. I'm just gonna
Oh, okay.
add a space to that comment so you can see that it's like it says changed.
Okay.
And so if I control S, well, I'll just do this file save. So that circle went away. If I close that and close my browser, I come back over here, my FileZilla window comes up and says, hey, do you want us to apply this change on the servers, on the Raspberry Pi side?
Oh,
And I say, yes. And so now on my Raspberry Pi, I have updated the Raspberry Pi script using whatever editor I want on my Windows 10 machine, which is, this stuff. And
okay.
if I get something over here on the right or on the left side and I want to put it on my Raspberry Pi, I just grab it and pull it over.
Oh,
And now it's on my Pi.
oh, nice. That's
So
using FileZilla. Okay.
yeah, and so um I'm not using the Raspberry Pi as an editor is really, I guess, the message that I'm trying to
Oh, okay.
deliver. And I'm not interacting with the user interface on the Raspberry Pi. I still, have effectively a Windows 10 user interface. Now I know you've got the iPad and your
I've got a
RPi,
link.
so maybe
Yeah.
that's all. Maybe those are the only two units that you have. But um, I was just mentioning this FileZilla and the process because for me, it's a little bit easier that way to
Yeah.
edit stuff and make sure I've got copies, and because now I've got it's a little bit easier for me to keep straight what's production, what's test, what do I want to have a backup for, and so on and so forth.
Yeah. I've got a laptop I could use kind of like your Windows 10 machine. So maybe
Uh, yeah, I mean, whatever works for you. I wouldn't make it more complicated. If you don't use that machine and it's dark and dusty and hasn't been used in a while, I'd probably stick with what you've got. But um, just make sure you've got a good backup and an easy way to back it up.
Oh yeah. Hard lesson learned. And I know better too, but
Yeah, and I probably learned it 3 or 4 times myself. So that's it for me.
yep, me too.
I was just playing with my background. I was thinking, can I here, let me turn it on and show you what it's doing. Choose virtual background. So I
Yeah.
turn it on, I get a weird say around my head, between my headphones and everything else, that it's showing through to my white wall behind me. And so I was trying to decide, is it worth setting up my green screen again? So I'm gonna have to maybe make a frame out of 1x3 pine boards and just lean it up against me and staple the green screen to it. So I don't have to start drilling holes in the walls, because that's going to annoy people if I do that. So maybe I just experimented, and yes, I can get my background, but it's got that strange halo around it like everybody has when they run a background with no. Here, let me. I was going to try this and see what this does. Let's say blur my background,
There you go.
and so it you can't, on the wall you can't see, there's actually a wall, but then again, see around here, it's doing funny things too. So yeah,
Oh,
if I want to use backgrounds, I really should set up my green screen again. So since I thought about it while we're doing this, I thought I'd go look at it. So do we have anything else for that we need to record, or should we turn that off?
Oh, on your green screen, is that a real green cloth or what?
Yes, it is. And you can just go on Amazon and say, look up green screen or something like that. And you can just buy, I think a bit like $14 for this thing. Is like 8 foot wide and 5 feet the other direction. And they meant to hang it the opposite direction that I wanted. So it's got a nice one end on the, so it'd be the narrow, they expect the narrow one. So at the top, it's gonna be 5 foot wide, and they got it folded over and sewn, so you can just put that over a rod or something. But I wanted it the other direction, so I turned it sideways. I just use clamps, like you go to Harbor Freight or Menards and the little spring clamps. I just folded over and clamped it onto that's the way I did it before. I bought a piece of 3/4 inch electrical conduit, and then got some curtain clamps and screwed those to the wall. And I put the metal rod up there, the conduit, and then I just folded it over the top and put the metal spring clamps on to hold it. Or
Oh,
they're
okay.
actually plastic spring clamps, but that's the way my original setup was. And after I moved, I haven't done anything with it. Just my cloth is laying on a chair over there, and I got to decide what to do with it. The other one to like put thumbtacks in the wall up at the top, but again, I have to worry about people complaining that I'm drilling holes in the wall or doing something. So
Yeah.
I could just get screw a single piece of wood across there and then just staple the green screen onto that. So it's just one more thing to be thinking about. So now I turned the blur off. You can see in my background, you can see the wall back here. You can see the texture on it.
Yep.
They put some really thick paint stuff in it, so it acts kind of weird. But anyway, so I'm gonna stop the recording if I can figure this out. They stop recording.